Minasan, konnichiwa. Zamurai Engineer desu. In this video, let us continue the discussion on Chapter 4 about simultaneous linear equations by use of Gaussian elimination. And there are two videos already made on this topic. One is the explanation of the procedure, and the other one is example. In this video, we will tackle the same thing on the topic of the pitfalls. What are the pitfalls in using this method? Okay, we have to be concerned about this. We have to know this so that we can avoid it. Okay, so for the application of the naive Gaussian elimination, pitfall number 1, division by zero. Division by zero in any procedure, in any event, must not happen. Particularly in mathematics, division by zero is not permissible. So let us have an example. We have 3 simultaneous linear equations here with variables x1, x2, and x3. And there are corresponding coefficients and equated to constant values. So we can form the required one, the matrix format. So we have the square matrix A, then the variable vector equal to constant vector. So we have the following using the 3 equations given. So 0, 10, -7. That is for equation 1, because the coefficient of x1 here is 0. Therefore, 0, 10, -7 is equal to 3. For the second equation, 6, 2, 3, 6, 2, 3, and 11. For the third equation, we have 5, -1, 5, -1, 5, and equal to 9. So we completed the matrix format of the simultaneous equation. So this simultaneous equation is just equivalent to this. Equivalent. And in fact, on the previous video, we used the what? The shorthand method of having this matrix format transform into extended matrix. Okay, so is division by zero an issue here? This is another problem here, because as you can see, we will be using 1. So if we divide all, because that is our first step. Our first step in this, our first operation is what? Divide by the coefficient of the first term. The coefficient of the first term is 0. To divide the whole equation by 0 is already not allowed. So pitfall number 1. But here, is there an issue here? I think not, because if we divide by 12, it will not be 0. It will become 1 and multiply by 6. So therefore, it will become 6. Okay? It will not be division of 0. Okay? So just an immediate observation. Let us take into deeper look. Is division by 0 an issue here? The answer is yes. Why? A. Not on the first equation, as you can see here. Okay, these 3 sets of equation. Okay, let's take a look. Not only in this type of setup, we have the division by 0 here, but here we also have the same problem because Okay. Okay. Let us first do the first operation, which is to transfer the simultaneous linear equation into matrix format. So 12, 10, negative 7. 12, 10, negative 7, and 15. So what's this? 6, 5, 3, 14. 6, 5, 3, and 14. And 24, negative 1, 5, 28. 24, negative 1, 5, 28. And then there are 3 variables, x1, x2, x3, and then write it down. x1, x2, x3. So this is how to write it down in a matrix format. Now, if you try to transpose this into what? Into the upper triangular matrix, immediately on the second equation, it will look like this, 0, 0. It will look like this, 0, 0. And because of that, okay, just transpose it. It will look like this. Division by 0 is a possibility at any step of forward elimination, not only in the first equation. It could also be possible other steps. So take care of dealing with division by 0, not only on the first equation. Okay, so if you use this, of course, we will have division by 0. How can we eliminate the first coefficient and the second coefficient of the third equation if we already have 0, 0 here? It is not possible because we will use the second equation in order to eliminate this one. How can we have the 12 here when if we multiply or divide, it will not become 12. It will not become 12 because the operation is multiply, divide. How can it become 12 when it is already 0, 0? So in order to make the 0, we have to use the first equation. But here, when we possibly do it when it is already 0 on the second equation. So let us have pitfall number 2. So number 1 is division by 0. Number 2, large round of errors. Okay. If we are not careful, rounding of errors would be a very big factor or very big influence on the final answer. So if we have this given problem and you are going to find out the solution, so you will have this type of solution: x1, x2, x3 is equal to 1, 1, 1. Okay, 1, 1. Okay, so please use your pen, paper, and calculator. I will ask you to solve this. Solve this using the procedure, format, and example on the first 2 videos of this Gaussian elimination topic. Okay, please solve this. Okay, number one, assign task. Assign task. Number 2, solve this. Is this the same? They are not the same. So solve that and also solve this one. 2, practice problem, and then solve this. Is this the same? It's not the same, so solve this. 3, and then solve this. 4. You have 4 practice problems here. You have 4 practice problems. Solve this if you can, and try to practice on your own. Now, if we do the same thing here, the same problem here, we do the same problem and solve it on a computer using 6 significant digits, meaning 6 significant digits 1, 2, 3, 4. This is just 4 significant digits. This has 1, 2, 3. 3 significant digits. This has 1, 2, 3, 4, 5, 6. 6 significant digits. If we do this on a 6 significant digit, the answer is not 111. Okay. So try this solving this one using other significant digits. For example, use 4 significant digits here. Okay. Solving the same thing using 6 significant digits manually, not using computer. The explanation is using computer, some program or some apps, but maybe we cannot have that apps because this type of method is naive Gaussian elimination. Maybe this is obsolete. Maybe this is obsolete right now. Nobody is using it right now. Okay, I don't know. I think it is obsolete right now, but it is used to teach. It is used to present example. It is used to present the concept. It is still important, but there are other methods that are better. So use manual computation, follow our procedure, and then instead of using 4 significant digits, using 6 significant digits. Okay, and then is this the same? So the same. Solve it on a computer using 5 significant digits. So using 4, using 6, and now using 5 significant digits. Okay, and then compare the result. You will notice different results come in. Different results come in. Okay. So, and another thing, use exact solution. Exact solution meaning use fraction. Use fraction. So 4 significant digits, 5 significant digits, 6 significant digits, and use fraction. Solve it by using fraction, meaning do not divide. Okay, do not actually divide. Just use the fraction. For example, 45. For example, here, negative 3 divided by 20. Do not divide 20 by 3. Okay. Okay. Just put the fraction negative 3 divided by 20. That is the exact solution. Don't evaluate the fraction. Okay. And using that is the exact solution, and find out what is the answer. So you have 4. You have 4 practice on this same problem. Try to do it. Try to do it. Don't be so concerned of your time. Be concerned on your learning. Which one is important to you right now? Of course, time is important, but which one is the important right now? Learning or time? Okay. Don't be concerned too much of your time. Be concerned on the learning first. If you already learn, then later on you can minimize time later on. Okay, you can minimize time later on. Okay, because you are learning, you have to allot more commitment on your time. Okay, so is there a way to reduce round of error? Avoiding pitfalls. Increase the number of significant digits. By increasing that, it will decrease round of error. Does not avoid division by 0. Okay. So by using the exact fraction rather than evaluating the fraction. Okay. Gaussian elimination with partial pivoting. So partial pivoting avoids division by 0. Reduces round of error. So let us take care of these 2 problems or pitfalls. Division by 0 and round of error. So, and this is the last slide. See you on the next video, wherein we will tackle how to do it, how to make it possible that those problems with assumed pitfalls will not be affecting our final result. Okay, so we'll have to modify our process, okay, with additional rules. Okay, so again, this is Dr. DrEYPEI, Teaching Engineering for Nation Building.